Okay, so I have three different lines here, and we know how to use the slope formula to calculate the slope of the line, assuming that we don't have a graph paper, right, to plot these points and do rise over run. So I want to find the slopes of each of these lines, and then we're going to look at them and kind of discover something using these. So we have our stack and subtract already set up and ready to go. We are subtracting, remember, our two y values minus each other and dividing them by the x values. So the change in your y values divided by the change in your x. Let's go. So we have 7 minus 5 in our numerator. That's our vertical distance. And then 1 minus 4 here. And that's going to be a simple 7 minus 5. 1 minus 4, or you could look at it as 1 plus a negative 4, right? So that's going to be negative 3. So the slope of this line is 2/3, okay? Let's keep going. Let's do a negative 2 minus 0 here. We're going to do negative 6 minus negative 5. And if we need a little reminder, I won't jump right to that. But a little something weird happens here. We need to remember that I have negative 2 and I'm not taking any away. This really means take away a fee. A fee is when you're charged something, right? So if you are taking away a fee, you're actually giving money back. So that's, don't subtract, add the opposite. And then that's going to give me negative 2 over negative 1, which the negatives cancel, and the slope of this line is 2. So if I were to plot those 2 points, I would see a rise of 2 and a run of 1. Let's finish this last one here, and let's take negative 1. The formula says subtract, so let's subtract a negative 1 from that negative 1. And let's do 3 minus 0. And this is going to give us a negative 1. Remember, if we need to kind of review our integer rules, we're adding 2 negatives, which gives me negative 2. 3, don't take any away. And so I want you to take a look at the slopes of these 3 lines here. And I know you might be looking at these two thinking, hey, they look kind of similar, except the negative is in the 3 in the denominator here, but in the numerator here. But remember, we talked about the quantity 2/3 is a one quantity, and the negative sign can be anywhere. It could be in the numerator, it could be in the denominator, it could even be right in the middle. So if you were kind of wondering if 2/3 with the negative up here is the same and down, yes, these are the same quantities. So these both represent 2/3. This one is a totally different number, and it's 2. So let's take these 3 lines and plot them on a piece of graph paper and see what we come up with. I heard you have them graphed here, so I want you to just kind of take a look at this and let's see if we can come up with a conclusion based on when lines have the same slope. So let me get this straight for you here, get the right amount of zoom. So as I'm looking at this line, I graphed the point 4, 5 here and 1, 7 here. So this orange line right here was our line A, okay? This, which is the slope of 2/3. So this line has a slope of 2/3. Then I went, I'm sorry, it was the negative 2/3. And then I went and graphed the 0, 1 and the 3, -1. And we noticed that these two, if you remember when I circled them like this, I put them in yellow highlighter because they were both the same. So I have a slope of a negative 2/3 here and negative 2/3 here. And pretty much looking at the slope of this line in this graph, it's pretty obvious to see that these 2 lines are running in the same direction. They're starting in different points, but they're both running down 2 and right 3. Down 2 and right 3. And what we notice about them is when lines run right next to each other like that, the word that we use is parallel. And the definition of parallel lines is 2 lines that will never intersect on a coordinate plane. So if I kept going down 2 and over 3, these lines would never, ever, ever meet the way that they are meeting this red line. And if you remember, this was line B, and the slope of line B was 2. And you can see that here because we would go up 2 over 1, up 2 over 1. So what I wanted you to gather from this activity was that when I calculate the slope of 2 lines, and the slopes are identical, then you can gather, not more than that, you can guarantee that when you plot those two lines that they will be parallel, okay? So I want to do like a little logic statement here. I had some geometry kids working on some logic chains the other day, and so I want you to just kind of take a look at what our conclusion could be for this. So if I were to say, and I want you to finish this sentence, if two lines have the same slope, and you're writing this too. So if two lines have the same slope, it's kind of like an if-then. Then what? If two lines have the same slope, then you know that they are parallel lines. Okay? If two lines have the same slope, then they're parallel. If I were to just kind of reverse that and say it in the other direction and say, if two lines are parallel, then what can you gather about those lines? What can you guarantee? If you look at a piece of graph paper and it has no points on them, it has no numbers, and it just shows that they're parallel to each other, then you know that they're going to have the same slope. I just said the same thing two different ways. So what I need you to understand is if I give you 3 lines to plot, you don't even really actually need to plot them. You need to just find their slope using that formula. And if they are the same, then you will tell me, yes, they are parallel. So if I were to say which lines are parallel, you would say lines A and C are parallel to each other because they have the same slope, but B is not.